The rule of indices says that if we have two powers of the same base, so in this case, first power is a to the m, the second power is a to the n, both have base a, so the bases are matching. So when that happens, multiplying the powers of same base, we keep the base and we add the powers. So our final answer here should be something like that. So just recapping the rules, and if we have another power, a to the m divided by a to the n, which is nicely written to using a fraction line, a to the m divided by a to the n, same as before, the bases are matching, so all we need to do is keep the same base and subtract the exponents. So just recapping, multiplication of same powers, add the exponents, division of same powers or bases, subtract the exponents. Now if we have what we call a power and another power, so power of a power, what we'll do here is we'll simply multiply the exponents, m times n, keeping the base. So let's see some examples. If we had 2x cubed multiplied by 3x squared, because it's all multiplication here, first we look at the numbers. 2 times 3 will be 6, and x cubed times x squared, what did we say? Multiplying powers of the same base, keep the base, and add the exponents. If you wanted to break this down, you could rewrite this as 2 times x times x times x multiplied by 3 times x times x. And then you will again do the same idea. Numbers first, 2 times 3 is 6, and x times x times x times itself 5 times will be x to the 5. If we had then 2x cubed divided by 3x squared, so first we would treat the numbers, but I probably would leave it as a fraction like that, 2/3, and then the powers have exactly the same base, so keep that base and we will subtract the exponents. So 3 minus 1, 1. So final answer, 2/3 x. If we wanted to visualize this in another way, we would say 2x cubed is 2 times x times x, divided by 3x squared would be 3x times x, and then we can do some simplifying. For example here, x can cancel out with x, meaning x into x goes once. We don't need to write that 1, but we can. And then again, x into this other x goes once. And I'm writing the ones, but I can simply now incorporate them in the calculation. 2 times 1 will be 2. X on the top, and on the bottom we have only 3 left. So same answer. Now let's say we have 2x cubed to the power of 2. So basically the brackets here are telling us to square not only the x cubed but also the 2 that is sitting at the front. So it actually means 2 squared multiplied by x cubed to the power of 2. So 2 squared, we can do that. First is 4. And what do we do with a power of a power? According to our indices rules, we will simply multiply the exponent. So keep the base, 3 times 2, 6. That's our answer. If we wanted to break this down a little bit, we could go to the basic idea of saying what is it to square an expression. It is to multiply that expression by itself. But then we could break this down even further. We could say, what is it to do a cube? It's to multiply the element by itself 3 times. And same here. 2 times x times x times x. And then we look at what we have in the end. We do the numbers as we always do first. 2 times 2, we have 4. And then x times x times x times x, x multiplied by itself. How many times here? 6 times. So that's where the 6 comes from. It's quicker to probably just remember what to do with them, but if we ever forget, we can always break everything down and try to go back to the original concept. Just one variation of this question. What if we had 2x cubed to the power of 2? Just look well at the two expressions that I'm highlighting in yellow and see what is different. The first expression, those pink brackets, are around the whole lot. Here, these pink brackets are only around the x cubed. So it means that 2 is not being squared at all. It stays as a 2. It's the x cubed that needs to be squared. And we know that power of a power will simply multiply the exponents. So x to the power of 6. So very different answers. And it's just the way the brackets are around the whole expression or around just one of the factors.